we have explained this example. But this session, we review this example and explain some details of this example. Suppose ut plus vux equal 0. X is bigger than p and smaller than q, and t is bigger than 0. With the initial condition, for the initial condition, we have u of x and 0 equal f of x for all of x between p and q. Ux and 0 is the initial condition. This is the value of the value of u at the first step size, at the first time. At the first time means at T1. At the first row in the mesh grid. In a grid, we have some row, first row, second row, third row, and so on. The first row is for T1. The second row is for T2 and etc. The initial condition is the value of u for T1 for the first step size. For T1, we know the value of u, the exact value of u for all of points from P to Q. For all of points from P to Q, we have the exact value of u, and the value of u is equal to f of x. At this example, at part A, we have used the forward finite difference approximation for spatial and time to find a numerical scheme to approximate u at a finite set of value of the independent variable. This part says, first you discretize the domain for x and for t. And when you compute the mesh grid, you use the forward finite difference approximation. For spatial means x and for time means t. And find the numerical scheme to approximate u at this grid. And for part B, we have set up p equal 0 and q equal to 100, v equal 0.5, n is equal 5, and delta t equal 3. And let the initial condition. In particular case, we have ux and 0 equal for x between 20 or 70, we have ux and 0, e power minus 201, x minus 45 power 2. And elsewhere and otherwise, we have the 0 value for ux and 0. When we put this value, we should compute the numerical solution. We start the solution first for part A. For spatial discretization, we start from the first point and move on by a step size delta x equal q minus p over n minus 1. The domain for x start from x, domain for x start from p to q, okay? We want to use endpoint. When we want to use endpoint in this domain, the delta x equal q minus p over n minus 1. Okay? And we should put p equal x1 and q equal xn. And we need delta x. For compute delta x, we put delta x equal q minus p over n minus 1. x1 is p, the next point is x2, the next point is x3, and so on. And we have xi, and the next point is x subscript I plus 1, and so on until we arrive to q equal to xn. You can see this discretization at this red box. x1 equal p smaller than x2, x smaller than x3, until smaller than xn equal to q. The first point is p, and the end point is xn equal q. And we know that xi plus 1 equal to xi plus delta x, for I equal 1 to n minus 1. This is the discretization for x, for domain of x, and for spatial discretization. It is familiar for you, and you know this discretization, yes? Clear for you. It's very easy for you because the last session and the previous sessions we discussed on this topic. Okay. Similarly, for discretization of time, we are going to discretize. Okay. Please repeat. Yes, I sent this file to you at WhatsApp. Now, after class, I will send this file to you via WhatsApp, okay? If we need at now, I can send to you at this time. Please let me to send this file to you at WhatsApp. Just a moment. I send to you this file. Please. You're welcome. This example is in the book, but very simple, very simple, and I describe this for you. I've sent this file to you at WhatsApp. Please check. Do you receive this file? Okay. Okay, I will continue.
سيما شنو هذا دزته بالواتساب؟
هسه الشرحة حاليا المثال صفحة 29.
اوكي اوكي.
Let me to continue.
Yes.
Okay. We are going to discretize time. For time discretization, we have similarly to spatial discretization, and we put T1 is equal 0. Maybe T1 not equal to 0. maybe T1 start from 1, start from 2, start from 100, start from 10. But at this example, T start from 0. This is optional. At this example, we have T1 equal 0. Maybe T1 is not equal 0. Please attention. T1 not always equal to 0. Maybe sometimes T1 is 1, 2, 3, or etc. Okay? At this example, we have T1 is 0 and smaller than T2, smaller than Tj minus 1, smaller than Tj, and it can be continued. And similar the spatial discretization, we have Tj plus 1 equal to Tj plus delta T for j equal 1, 2, 3, and so on. The value of u for mesh point are u, I, j. I can be subscript and j can be superscript. I is subscript, j is superscript. And you can write u, I, and j. You can put I and j as a subscript. And for both of them is equal to u of xi and tj. Where u, I, and j means the value of u at xi and tj in the mesh. In the mesh, this point is x, the coordinate of this point is xi and tj, and the value of u at this point are u subscript I and j, or we can write u subscript I and superscript j. Both of them are correct. For I start from 1 to n and j start from 1 to and so on. In this example, we should use forward finite difference approximation. At the part A, we have use forward finite difference approximation for spatial and time. And we should apply for ux ij equal to ui plus 1 and j minus uij over delta x. It's forward finite difference for a derivative of u respect x. And ut I and j equal ui j plus 1 minus ui and j over delta t. This is the finite difference, forward finite difference approximation for the derivative of u respect t. By replacing these two approximations in PDE, our PDE is ut plus vux equal 0. We replace this approximation ux and ut in this PDE. For u respect dt, we replace ui j plus 1 minus uij over delta t. It's an approximation for u respect t. Then we have plus v, and we write plus v. And for u respect x, based on forward finite difference, we should write ui plus 1 and j minus uij over delta x. This is an approximation, forward approximation for u respect x. and then we have these terms equal to 0. Is it okay until here? Is it clear for you until here?
Yes.
Okay. When by rearranging and compute ui and j plus 1, we have ui and j plus 1 equal ui and j minus v delta t over delta x ui plus 1 and j minus ui and j. This scheme is called time marching scheme, okay? If we can see this equation carefully, we can see that the right-hand side of this equation is based on J, is based on the Tj, and the left side is for J plus 1. When we use delta x and delta t, then we use the forward approximation for ux and ut, we have the order of error for ux is O delta x, and order of error for t is O of delta t. And we said equation 2 is said to be first order in space or x and first order in time. This scheme is the first order in space and the first order in time because the order of error for x and t is 1 and 1. Okay? This equation is a finite difference scheme. FDS means finite difference scheme. This equation means the equation 2 is FDS to approximate the solution of the PDE A with the initial condition 1B with the I point C point means initial condition. We use I point C point for the initial condition. 1A and 1B is the main PDE. It's here. Please see this equation. At the first page, we have ut plus vux is 1a, and the initial condition ux and 0 equal f of x is 1b. This is our PDE, okay? And this and the equation 2 is approximate scheme for this PDE with the initial condition means 1b. The equation 2 is said to be an explicit method. Why we call this explicit method? Which of them can you describe? Why we say the equation 2 is explicit? Why? For the next session, please research and say to me what this equation is called explicit method. Okay, it's an exercise for you for the next session. For the next session, you will research and find why this formula for this, why this equation 2 is said to be is called an explicit method. Okay؟ بر جلسه دیگه به عنوان تمرین برای من باید ارسال کنید که چرا میگید این فرمول 2 صریحه، فرمول ضمنی نیست، چرا explicit متد هستش. اوکی؟ The next note is the equation 2 is so-called time marching scheme, which enables u value at time level j plus 1 to be approximate from u value at the previous time level j. Okay, this scheme is called time marching. This equation 2 is called time marching scheme. Why? Because we can compute u at the next step size by using the value of u at the previous step size, and then we call this scheme, this equation is time marching scheme. Since all u value are known exactly at the initial time level, why we have the exact solution at the initial time level? Which of them can you describe? Why the value of u at the initial time is exact? It's not approximate. The value of u at the initial time is exact. چرا؟ سوالم اینه. چرا مقدار u در زمان اولیه دقیق هست، تقریب نیست؟ Which of them can you answer me? I put a positive grade for him or his. هر کس بتونه توضیح بده نمره مثبت داره. چرا ما در زمان T1 در زمان شروع در اینیشیال تایممون جواب واقعی داریم، جواب تقریبی نداریم؟
وياي أساتذة لا تسأل سؤال تقول هذا الثالثة هي هاي ثلاثة الموجود عندنا، تقول ليش عندنا الوقت مالتنا مو جزئي؟ واللي تقول اللي تجاوب أعطيه درجة، يعني أعطيها درجة على شهري.
If you focus on the PDE, you can answer to me very easily.
هم باقي الان میخوایم برای هفته دیگه.
الان بگی چرا در زمان اولیه‌مون جواب‌هامون دقیق هستن، تقریبی نیستن؟ یعنی تو سطر اول، یعنی در T1 چرا جواب‌های ما دقیق هستن، تقریبی نیستن، و در بقیه سطرها تقریبی هستن؟ Why our solution is exact at T1 but for T2, T3 and so on we have not the exact solution.
تقول ليش الوقت الابتدائي مالتنا اللي T1 دائما يكون بالضبط، واللي وقت اللي بعد الواحد يعني اللي يصير T2 T3 إلى ما لا نهاية راح يكون تقريبي.
Because of initial condition. Because initial condition.
شلون وقت شروعش فکر کنم از صفر شروع میشه.
I've said to you we have the exact solution of u at T1 because we have the initial condition. Okay, I've said to you here, I've said to you at T1 we have the exact solution. The exact solution at
بالضبط. ليش بالضبط الوقت الابتدائي؟ خلينا نقول كان على الصفر شروع مشي، يعني أنا أقول لأني يبدأ من الصفر.
خانم طالب، ما در زمان اولیه‌مون در زمان شروع، خب حالا میتونه صفر باشه، یعنی صفر
نباشه. از وقتی که شروع میکنیم من وقتشو داریم.
دقیقاً مقدارشو در زمان اولیه‌مون داریم. اینجا گفته از صفر، ممکنه صفر نباشه، ممکنه 2 باشه،
صفر نباشه، 2 باشه،
ممکنه 10 باشه،
ممکنه 10 باشه. ولی همین 2 و 10 از اولش که شروع میکنیم از همین نقطه شروع میشه. 2 و 10 شروع میشه.
بسیار عالی. یعنی دقیقاً تو اون زمان
مثبتشو بذاریم پس.
چی؟
نمره مثبتشو بذاریم پس.
خودم گفتم اینیشیال کاندیشن.
خودم هم قبل.
اوکی،
من
مشکل
نداره.
خب براتون در نظر میگیرم، مشکل نیست. فقط من خانم زینب یه بار توضیح میدم، میخوام بچه‌ها اینو یاد بگیرن. لطفا شما حالا فکر نمی‌کنم وارد انگلیسی رو خیلی خوب متوجه بشن، براشون لطفا به زبان عربی بگین. ببینید اینجا تو این مثال از 0 شروع شده. ممکنه 0 نباشه در مثال‌های دیگه. ممکنه 2 باشه، 3 باشه، 10 باشه یا هر عددی باشه. ولی به هر حال هر عددی که اینجا می‌نویسیم میشه T1 ما. درسته؟ میشه نقطه زمان شروع ما. در زمان شروع ما مقدار دقیق یو رو داریم، نمیخواد تقریب بزنیم. از کجا داریم؟ بر اساس اینیشیال کاندیشنمون داریم. بر اساس شرط اولیه در زمان حرکت، در زمان شروع حرکتمون ما مقادیر واقعی رو داریم، تقریب نیستن. لطفا زحمت بکشین اینو براشون توضیح بدید. ممنون میشم از شما.
خودم متوجه شدم، بذار بگم.
خیلی
ممنون. وياي انتبهتوا ويا هالسؤال. شو تقول ليش بوقت الأول الابتدائي اللي هي T1 عندنا اليو بالضبط، راح يكون اليو مالتنا راح يكون يعني بالضبط اللي قد قيمة اليو. تقول ليش بالقيمة T2 T3 إلى T ما لا نهاية راح يكون تقريب مو بالضبط يساوي، يعني بالT1 راح يكون عندنا الناتج يساوي، وبالوقت اللي وراها راح يكون التي تقريب مو يساوي. انا ايش قلت لها بما ان عندنا التي صفر، عندنا يعني يبدا من نقطه الصفر، قالت احتمال مو صفر، احتمال 2 10، هذا اللي قبالنا مكتوب. اوكي قلت لا هي شو تقول؟ لا تقول مو حد الادنى، احنا نقطه الشروع البدايه انشيال كونديشن، هاي اللي كاتبت لنا اياها. تقول ايه هي شرط الابتدائي مالتنا الوقت نفسه بالضبط. انا راح ابدي يعني قيمه التي انا موجود عندي، فاكيد راح يكون عندي قيمه اليو مساواه الها. انا جاوبتها، هي تقول لي لا. انا قلت لها لا، وانا قلت لك من البدايه انت كاتبت لي الصفر. قالت لي اذا 2، قلت لها عادي ما عندنا مشكله. زين، فراح يكون اذا بالبدايه initial condition راح يكون اليو مالتنا بالضبط يساوي، واذا بما انه راح يتغير التي عندنا بالتغير راح يصير عندنا تقريب قيمه اليو.
Are you clear for all of you? Yes? Are you understand?
Yes.
We have some step size for T, T1, T2, T3, and so on, okay? At the first level, at the first step, we have the exact solution based on initial condition. U of x and 0 means the U of x and at T1, at the start point of T. Start point of T at this example is 0. But maybe a start point is not 0, okay? Oh, and at this example, we have T1 is 0, and the start point for time is 0. Okay, continue. Since all U value are only known exactly at the initial time level, initial time level means T1. The value of U at T1 is exact because the initial condition. And we can use Uij plus 1 equal to Ui and j minus V delta T over delta X, Ui plus 1 and j minus Ui and j. Okay. At this equation, we use the U, small u, instead of big U. Why? Ui and j with the small u is an approximation to Ui and j for big U. Okay? A small u is the approximation to u, means u at xi and tj is approximate by a small u, I and j. A small u is an approximate for big U at xi and tj. Each grid point at time tj is used to find data at each grid point at the next time tj plus 1 equal tj plus delta x. This is called an iteration of the scheme. Please attention. When we have time tj, when we are in the time level tj, we have the value of u at this time. We have u1 and j for each a, and we have u2 and j, and finally we have un and j. These are the data at tj, u1 and j, u2 and j, and finally un and j are data at tj. Okay, we can use u1 and j, u2 and j, and un and j to get the value of u at tj plus 1 based on 3. 3 said based on uij, ui plus 1 and j, you can compute the value of u at the next step. Okay? After an iteration, the all value of u at this time level are known, and we can go to the next level. خانم زینب ببینید چی میخوام بگم. نگاه کنید این فرمول شماره 3 رو نگاه کنید. در فرمول شماره 3 سمت راست، در فرمول شماره 3 همه ما اطلاعاتی که داریم از زمان j هست، در tj هست، درسته؟ پس اگر ما u ها رو در زمان j داشته باشیم میتونیم یه گام جلو بریم، میتونیم یه گام جلوتر بریم و مقادیر u رو در گام زمانی بعدی به دست بیاریم، درسته؟ یعنی مثلا من t1 رو اطلاعاتش دارم، میرم باهاش u های گام t2 رو میسازم. حالا u های گام t رو دارم، میرم جلو باهاش u های گام t3 رو میسازم. پس با using the value of u at the tj we can go to compute the value of u at the tj plus 1. اینو لطفاً بهشون بگین که گام به گام میریم جلو.
درسته. تقول احنا راح بدينا بالقانون الاول، القانون الثاني هسه هذا قانون الثالث. يقول ايش قانون الثالث؟ شنو القانون الثالث؟ اللي هي يو للاي وجي زائد 1. يعني انا ايش قد عندي اللي اي ثابت، شنو هو راح ازوده الفورورد مالته؟ جي زائد 1. امشي يعني انا اريد مثلا اريد الجي زائد 1. القانون مالته ايش راح يصير؟ الايات شوفوا انت وياي، الايات كلهن ثابتات، يو للاي يو للاي يو للاي ثابتات. راح شنو هو راح ازوده؟ راح امشي التغيير مالتي على اليمين، عفوا الجيات كلهن ثابتات، وامشي على اليمين على الايات. الاي بالاول وحده اول يو للاي جي، بين قوسين عندي اي زائد 1 والجي ثابت ناقص يو للاي والجي. يقول لك اريد اطلع اللي وراها ازود من هو الاي مالتهن، كل ما امشي على الجي ازود الاي بالقانون. اوكي قام باقري فقط یو کاپیتال اسمول ولا متوجه نشدین؟
یو چی؟
یو کاپیتال اسمول.
نگاه کنید این مقدار واقعی ها هست، چون ما تقریب میزنیم از یه کوچک استفاده میکنیم براش.
بله بله بله.
من نماده، یعنی ما میخوایم یک فرقی بین جواب واقعی و جواب تقریب قائل بشیم، به این خاطر یو بزرگ برای واقعی، یو کوچیک برای تقریب استفاده میکنیم.
هذا قانون، هذا قانون. الجي اللي أكبر فورورد بالنسبة للجي، شفتيهن؟ يعني مثلا عندي 1 و3 بالقانون ايش راح يصير عندي؟ ثلاثة الجيات مالتنا الأصغر من عده، أنا أمشي أريد الثالث بس أمشي على اليمن على الأقل من عده. أنت تخيلي مثلا، تخيلي الجي زائد واحد يعني إيش فرضا إيش قد بالقانون إيش راح يصير عندك؟ يو للآي للثنين، الجي مالتش للثنين، يعني أنت لازم بالسرة تمشين من الواحد تطلعين الواحد تعوضين بالثاني، تطلعين الثاني تعوضين بالثالث، تعوضين بالثالث زائد ايه.
Okay,
انت طلعتهن
please,
انت
I
طلعتهن من
repeat
الصور
this
قبلها،
formula.
من قانون قبله، من الثاني.
I repeat, please attention to me. You should understand Persian language because your thesis should be written in Persian. Try to understand Persian. Okay? تلاش کنید فارسی یاد بگیرین. اینجور که من حالا تا اینجا شنیدم باید پروپوزال شما و پایان نامه شما به زبان فارسی باشه. تلاش کنید فارسی رو هم یاد بگیرید، براتون مفیدتر. این کلاس ها بهترین موقعیت هست برای اینکه شما فارسی رو یاد بگیرید. The thesis and your thesis and your proposal should be written in Persian. Try to understand Persian language. Okay, I repeat. The equation 3 is ui and j plus 1. And the right side is ui and j minus v delta t over delta x, ui plus 1 and j, and ui and j. For example, if we should compute ui and 2, what about this equation? Ui and 2 is the value of 2 in the second row. We have ui and 1 minus v delta t over delta x, and we have ui plus 1 and 1 minus ui and 1. ui plus 1 and 1, ui and 1, ui and 1. We have the exact solution for this based on initial condition. And we can go to the next time step and we can compute ui and 2. When we compute ui and 2, I can use from this value and compute the ui and 3. ui and 3 equal to ui and 2 minus v delta t over delta x, ui plus 1 and 2 minus ui and 2. When we move from T1 to T2, it's called an iteration. So an iteration is the move from the time level j to the next time level. For example, tj plus 1, that equal to tj plus delta t. This new value, when we compute ui and j plus 1, we do an iteration. And the new value can be used as known data. When we receive to tj plus 1 and we compute the numerical solution at this time level, the value of u at this time level is known. And we have the known data at this time level, and we can continue the iteration and go to the next time level, and we compute the value of u of the next time level. process can be repeated until the required time. When we receive at the required time, we can stop. Okay, we go to the part B. In part B, we have let T equal to 0, Q equal to 100, V is 0.5, N is 5, and delta T equal 3. Means we have this point. The first point P is equal 0, and the end point Q equal 100. Okay? And we should consider N equal 5. We have 5 points. When we have 5 points, delta X equal Q minus P over N minus 1. And we have Q is 100, P is 0, and N is 5. And we have delta X equal 25. Then we start from P equal 0. P is X1. X1 is T. And for the next point means X2. X2 is X1 plus delta X, and we have X2 is 25. The next point is X3. X3 is 25 plus delta X, means 25 plus 25, and X3 is 50.
Okay.
For the next point means X4, we have 50 plus delta X. 50 plus 25 is 75, and X4 is 75. And finally, for the end point X5, we have 75 plus 25 is 100, okay? And X5 is 100. Then we have X1 is 0, X2 is 25, X3 is 50, and X4 is 75, and finally we have X5 is Q is 100. We have 5 points, X1, X2, X3, X4, and X5. We have 5 points, okay? X1 from X1 to X point. At part B, we have delta T is equal to 3, okay? And the initial condition is Ux and 0, means U at the first time level is e power minus 0.01 x minus 45 square for x from 20 to 70. For x from 20 to 70, we have Ux and 0 is e power minus 0.101 x minus 45 power 2, and elsewhere or otherwise we have 0. Then the equation theory, based on equation theory, the equation theory is ui and j plus 1 equal ui and j minus v delta t over delta x ui plus 1 and j minus ui and j. This is the equation 3. This is here. Please attention. This is here. This is equation 3. I repeat this equation here. I repeat this equation here. Okay? Then we replace v by 0.5 in part B. We have v is 0.5, delta t equal 3, and delta x equal 25. Okay? When we replace this value for v and delta t and delta x, we have ui and j plus 1 equal to ui and j minus 0.06 ui plus 1 and j minus ui and j. 0.06 is the value of v delta t over delta x. Is it clear for you?
باقی قیمت وی خودش تو سوال بهمون داده؟
بله اینا هاش نگاه کنید دقیقاً در قسمت بی گفته وی رو چی بگیرید؟
بله.
این بگیرید. P is 0, Q is 100, V is 0.5, N is 5, delta T is 3. Okay? All of you please attention. We have the value of V. The value of V is 0.5. Okay? Here we have the value of V. Delta T equal to 3. Delta T equal to 3. And we compute delta X and the result is 25. When we replace this value and compute, the result is 0.06. Okay? And the equation 3 change to ui and j plus 1 equal ui and j minus 0.06 ui plus 1 and j minus ui and j. For which I and which j? For I start from 1 to 5 because we have 5 point. We have 5 point start from x1 to x4. We have 5 point x1, x2, x3, x4, and x5. And what about j? J start from 1, 2, and so on until the time that we want. Okay, first we put j equal 1. Please replace j is 1. When we put j is 1, we have u, I, and 2, okay? Equal u, I, and 1 minus 0.06 u, I plus 1 and 1 minus u, I and 1. You can see this at this line. When we put j equal 1, we have this formula of this equation. ui and 2 equal to ui and 1 minus 0.06 and ui plus 1 and 1 minus ui and 1 for I equal 1, 2, 3, 4, and 5. Okay. At this formula, we need the value of u at the first step size t1. Please attention, ui plus 1 and 1. The level of t is 1. The right side is based on t1, okay? And then we need the value of u at first time step t1. Based on initial condition, we have ux and 0 equal. It is a repeat. For x between 20 and 70, we have ux and 0 is e power minus 0.01 x minus 45 power 2, and elsewhere is 0. U, I, and 1, the exact solution of u at the t1 is equal to approximate solution. We have the exact solution based on the initial condition. ui and 1 is equal to ui and 1 based on the initial condition, and the solutions are exact because of initial condition. We compute the value of u at t1. Please attention. This is the time level t1. This is the time level t1 equal to 0. We have 5 points at this level time: x1, x2, x3, x4, and finally x5. Okay? At this first point, we compute u1 and 1. At the next point, we have u2 and 1. For all of them, the index of t is 1 because t1 is constant at this row. For the next point, we have u3 and also 1. For the next point, the value of u is u4 and y. And finally, we have u5 and 1. Okay? We know this value of u based on initial condition. For example, we are going to compute u1 and 1. u1 and 1 is u of x1 and t1. The x for u1 and 1 is x1, and the t for u1 and 1 is t1. u of x1 and t1, x1 is 0, and t1 is also 0. We have x1 0, x2 25, x3 is 50, x4 is 75, and x5 is 100. Okay? So ux1 and t1 is u at 0 and 0. Please attention to initial condition. Initial condition says if x is between 20 until 70, we use this formula, and otherwise use 0. x1 is 0, and 0 is not bigger than 25. And we have for u0 and 0 equal to 0. The value of u at this point is equal to 0. Is it okay for you? u0 and 0 is 0.
Yes, yes.
For the next point, u2 and 1. We are going to compute u2 and 1. u2 and 1 equal u of x2 and t1. x2 is 25, 5, and still we have T1 and T1 is 0. We return to initial condition. U25 and 0, x is 25, and 25 is bigger than 20 and smaller than 70. And we should use the first case, e power minus 0.01 and at x minus 25 power 2. And replace x by 25. We computed this value. We have u2 and 1 is 0.0183. It is the value, the exact value of u at T1. u2 and 1 is 0.183. Okay? Are you understand?
Yes, yes.
Please, all of you, answer to me. Do you understand?
عوضناها بالقيمة. شوفوا باعي
Yes, yes.
قيمة exponential بexponential. إذا بين الصفر والسبعين قيمة x باعياها. إذا بين 20 و70 أعوضها. وإذا مو قيمة بين الإكس وال70 راح أعوض الناتج مالته يساوي صفر. شوف الثلاثة الأخيريات صفر. ليش؟ لأن عندنا قيمة إكس 75 و100 وصفر. عوضت صفر. بس هذين الاثنين والثلاثة ليش؟ يعني عندنا 25 و50. بين 20 و70 عوضتها بالإكسبوننشال. التي صفر هو بالقانون. شوفي هسه هنا أنا مطيت إياه ماكو إلا صفر بهذا القانون. خان باقي لميقان أجي قيمة تي صفر نابوشة.
حالا بهش میریم جلو. فعلا تا اینو یاد بگیریم.
هسه حاليا مو قلت لك أنا هسه حاليا على هذا السؤال صفر. اوكي.
Are you understand until now, until here? تا اینجا یاد گرفتی؟
هنا واضحة؟
اوكي.
يعني بس بهذا السؤال زينب صورتي.
اي هو محدد لك ميول الاكس الصفر. هو محدد لك وين ما عدت تي صفر الناتج مالتنا راح يكون يساوي صفر.
اوكي.
Okay. For the next point means x3. x3 is 50. u3 and 1. We are still at T1. Please attention. We are still at T1. We are not go to the next time. We are still in the first level time. We are at T1. u3 and 1 is u of x3 and T1. x3 is 50 and we have u of 50 and 0. Based on initial condition, we have for u of 50 and 0, x is 50 and 50 is bigger than 20 and smaller than 70. Okay? And we can use the first case of initial condition. We should use this first formula. If we put base 50 instead of x and we compute this exponential formula, we have u3 and 1 is 0.7788. And we can compute u3 and y 3 and 1 based on initial condition. And the value of this point, the value u of this point is 0.7788. We go to the next point at x4 and still T1. We are going to compute u4 and 1. For u4 and 1, we have u of x4 and T1. Means u at 75 and 0. 75 it is not between 20 and 70. 75 is bigger than 70, and the value of u at this point is 0 without any computational. And we have u at 75 and 0 is 0. And similar at this point we have for u5 and 1 means u at x5 and t1, and we have u at 100 and 0, and the value of u at this point is 0. I collect this value at this table. The first row is the value of I. We have 5 points. I equal 1, I equal 2, I equal to 3, I equal to 4, and finally I equal to 5. For this index, we have xi is first point is 0, the second point is 25, the third point is 50, the fourth point is 75, and the end point is 100. U and 1. Based on this computational, based on this compute, we have u and y equal to u of xi and t1. Based on initial condition, we have 0 for I equal 1. We have 0.0 183 for I equal to 2. We have 0.7788 for I equal to 3. And we have 0 and 0 for I equal to 4 and for I equal to 5. Until here, do you understand?
Yes,
We collect this value based on initial condition in this table. Okay? Okay. The result of this step is the value of u at t1. But the equation 3 is for every j. Please attention. Ui and j plus 1 equal to ui and j and so on. It can use for every day. And for the next time, for the approximate solution at the next time step, we have T2 equal to T1 plus delta T. T1 is 0, delta T is 3, and the T2, the next step size is 3. T2 is 3. When we write the equation 3, we have T, U, I, please let me, U, I, and j plus 1, it is index. Okay. U, I, and the next step size means j plus 1 equal to, I'm writing the equation 3 because we have not this equation at this page. I try to write it. And it's very hard. U, I, and j minus Please let me to correct my screen. My pen is incorrect. Okay, please excuse me. My pen is writing itself. پن من خودش داره مینویسه without I trying to write. U, I, and J. I hope my pen is correct. Minus 0.06 U, I plus 1 and J minus U, I, and J. Okay, we have this equation. This is the equation 3. Okay, you should put J equal to 1. Okay, when we put J is 1, we have U excuse me, my pen is interrupt. Okay, U, I, and J plus 1, when we put J equal to 1, we have U, I, and 2 equal to U, I, and the previous step size means U, I, and 1 minus 0.06 U, I plus 1 and 1 minus U, I, and 1. Okay, this is the main formula, and we put J equal to 1 at this formula. Is it do you understand? We put J equal to 1 at equation 3. Okay? Is it okay?
Okay.
این همون فرمول قبلی هست، فقط ما به جای J چی گذاشتیم؟ 2 گذاشتیم.
دو گذاشتیم. بله.
حالا when we write this formula first for I equal 1 and we put U 1 and 2, then we put I equal to 2 and compute U2 and 2, and then we put I equal to 3. The next line, at this line we put I equal to 3. For the next value, we should put I equal to 4. And finally, we should put I equal to 5. Okay? For the first case, when we put I equal to 1, we have U1 and 2 equal to U1 and 1 minus 0.06 U2 and 1 minus U2 and 2. This is based on this formula. Based on this formula, and we put I equal to 1. When we put I equal to 1, we have u1 and 2 equal to u1 and 1 minus 0.06, u1, 2 and 1 minus u1 and 1. The value of u at the T1 are written at this table. At this table, we have the ui and 1. u1 and 1, u1 and 1 is 0, and we put 0. u2 and 1, u2 and 1 is 0.184. 0 is deleted here. It's mistake, and in writing this mistake is caused. u1 and 1 is 0, and we write 0. When we compute these terms, we have minus 0.001 and 1 for u at x1 and t2. Please attention. I describe this geometric. It is time level T1, and we are going to time level T2. We are going to time level T2 and compute the value of u at this time. This is T2. Okay. x1. The next point is x2. This is x1. This is x2. This is x3. This is for this is for x4, and this is for x5. This is T1, and this is T2. The value of u, we have u1 and 1, u2 and 1, u3 and 1. All of them is now u1 and 1, u2 and 1, u3 and 1, u4 and 1, and finally u5 and 1. All of them is known. We are the value of them exactly based on initial condition. And at this point, we have u1 and 2. This one is u2 and 2. For this point, we have u3 and 2. For the next point, we have u4 and 2. And for the next point, we have u5 and 2. Okay? First, u1 and 2. u1 and 2, we compute this value. And the value of this point is minus 0.0011. For the next point, u2 and 2. For u2 and 2, the formula is u21 minus 0.06, u3 and 1 minus u2 and 1. All of them is the value of u at T1, and the value of u at the T1 is known. When we replace the value of u21, we have the value of U21, and you can see this value at this table. U2 and 1 is 0.0183. U3 and 1 is 0.7788. U3 and 1. And again, U2 and 1 is 0.0183. We have the value of all of them. And when we compute this line, the result is minus 0.0273. And then we compute U2 and 2. And now we know the value of U1 and 2 and U2 and 2. Then we are going to the compute value of U3 and 2. The formula for U3 and 2 is U3 and 1 minus 0.06 U4 and 1 minus U3 and 1. The value of this U are again is table, the above table. And we should replace the value of this U. U3 and 1 is 0.7788. U4 and 1 is 0. And again, U3 and 1 is 0.7788. And when we compute this line, the value of U3 and 2 means U of X3 and T2 is 0.8255. And now we have the value of U at U3 and 2. For the next point, we are going to compute the value of U at X4 and T2. For U4 and 2, we have U4 and 1 minus 0.06, U5 and 1 minus U4 and 1. All of them is the value of U at T1, and the value of U at T1 is known. U4 and 1 is 0. U5 and 1 also is 0, and the value of U4 and 2 is also 0, and we have U4 and 2. And we are going to the end point of U at X5 and T1. We are going to compute U5 and T. When we write the formula for U5 and 2, we have U5 and 1 minus 0.06 U6 and 1 minus U5 and Y. Do you have the value of U at U6 and 1? What's the value of U6 and 1? At T1, we have U1 and 1, U2 and 1, U3 and 1, U4 and 1, and U5 and 1. We have not U6 and 1, okay? Do you have the value of U6 and 1? No. The end point is X5. We have not X6, okay? And we cannot use by this formula U5 and 1. There is a problem. What's the solution for this problem? You cannot don't compute U5 and 2. You should compute U5 and 2. Until now, until here, we stop, and you can go to rest and come back to class and continue this U5 and 2. تا اینجا استاپ میکنیم. 15 دقیقه استراحت داشته باشید، بعد برگردین که بحثمون رو ادامه بدیم با این قسمت. اوکی؟
اوکی.